Hi, welcome to our second example. In this video, we're going to apply the sine law to solve a problem in 3 dimensions. So I actually really like this question because it is quite practical. So sometimes surveyors need to determine the heights of objects that are very difficult to measure, such as a cliff with a river in between. So they can take a few known measurements and then applying a little bit of trigonometry, they can actually determine objects or features that can be very difficult to measure. Okay, so it says here, a surveyor is on one side of a river. On the other side is a cliff of unknown height that he wants to measure. So we're going to be trying to find this height. The surveyor lays out a baseline AB of length 150 meters. So the surveyor is on this side of the river, and she lays out a baseline from point A to point B, 150 meters long. Okay, from point A, so from this point, she selects a point C at the base of the cliff. So maybe it's a funny looking rock that you can recognize. And it says she measures CAB to be 51. So the surveyors have special cameras and they can rotate them and they can actually record angles. So she looks at that special funny rock and then looks at her other point B and she measures this angle to be 51 degrees. That's angle CAB. Okay, then it says she selects point D on top of the cliff directly above C. So directly above C, she selects another point D at the top of the cliff. Okay, and she measures the angle of elevation to be 32 degrees. So the angle of elevation is always an angle that's measured from the horizontal. So her camera would be looking directly at C, nice and horizontal, parallel to the ground, to the river. And then in order to look at the top, it would have to rotate up 32 degrees. Okay, she moves to point B, so at the end of the baseline, and she measures CAB to be 62. So she'd have to set up her camera to look at C, and then she rotates it back to the baseline, and then she records that measured angle of 62. So this is a 3D question because we have a nice triangle right here that's kind of parallel to the ground. And then we also have another another triangle. This one happens to be right angle. That's kind of more in a vertical plane. Okay, we are looking for the height of the cliff. So I know it doesn't say that here, but the question wants to find the height of the cliff. Okay, that's basically going to be CD, right? I'm trying to find the distance from point C to D. Okay, so to do any of these questions, it's important that we clearly establish the triangles that we want to use. We want to take what we're trying to find and work backwards. Okay, so if I'm trying to find the height of this cliff CD, I need to know what information do I need in order to find this. So we have a nice right angle triangle. We have this angle right here. If I'm trying to find this opposite length, I'm going to need one other piece of information. It's going to be too hard to find the hypotenuse. There's nothing given to help with that. But perhaps I could find the base of that triangle right here from AC. If I had AC, I could easily use tan and find the height of the cliff right here. Okay, now can I even find this? I think so. We have an angle here, we have an angle here, we have a length 150. I'm pretty sure we could actually just do maybe a little bit of sine law or cosine law. Okay, can I use SOHCAHTOA? I don't think so. This is not 90 degrees here. So 51 and 62, that makes 113. So that means this is less than 90. So no, we definitely don't have a right angle there. So we'll have to use sine law or cosine law. Okay, actually tells us in the beginning up here that we need to use sine law. Okay, let's get started. So I think the first thing we can do is we can try to find AC. Okay, so step one, okay, find AC in triangle ABC. Okay, we're probably going to have to do two things to do this. So to get AC, I think I can use sine law, but I need this pair right here. I don't have it, so because I have this length, I probably want to pair up with that angle there. So if I could find the angle at ACB, I'll have a nice pair right here, and then I can use sine law to find this missing length right along there. Okay, so we're gonna, we'll say here find, I'll call this step I, and I'll say find angle C. So angle C is going to be equal to, actually to be a little more specific, we'll say ACB, right? Angle ACB. That way we know we're working with this triangle. Angle ACB is going to equal 180 minus the other two. So minus 51 minus 62. And that works out to 67 degrees. Okay, so that's my angle C at the base here. Okay, now I'm going to apply sine law. To find this length here, AC. Okay, AC, I'm calling it AC, but it's actually opposite to B, so I could just call it little b. Okay, so that's what I'm going to do when I do the sine law. Okay. So I always write what I'm looking for first. So we're going to have B over sine B. That needs to be equal to another pair that I know. And we just found angle C, so I could do angle C and side length C. So we'll say little c over sine C. Okay, let's plug in what we know. Angle B is 62. Just going to check that. Yeah, angle B is 62. And angle C was 67. Okay, and length C was 150. Yeah, length C is 150. Okay, multiply both sides by sine 62. That way that cancels. And we can say B is equal to 150, sine 62 over sine 67. (150) times sine of 62. Take all that, divide it by sine of 67. 143.87. So we're just going to round up to 144. Okay, so that's great. We now have this piece of information here. AC is 144. Okay, finding the height of the cliff, real easy now. Okay, we have a nice right angle triangle with ACD, and we have one length and we have one angle. So it's really easy to find the opposite. Okay, I'm going to call this H. Okay, that's what we're looking for. Okay, I'm going to call this step 2. I'm going to say find H in triangle. It would be ACD. Okay, it's a right angle triangle. Remember, it looks kind of like this. Okay, what's our angle? 32. And we found the base to be 144. And we're looking for the height. So this is now a really easy question. Opposite to this angle is the height that I'm looking for, and I'm given the adjacent. So we should use tan. Tan of 32 is going to equal h over 144. Multiply both sides by 144. Cancel that out. So h is going to equal 144 tan 32, which will be approximately 89.98, approximately 90. Okay, so there we have it. We just solved for the height of the cliff, which would otherwise be very difficult to measure. Okay, that is it for this video. I'll see you guys in the next one.